We are solving question number 38 of GATE 2018 chemical engineering paper related to fluid mechanics. The question is, at a shear rate of 10 second inverse, the apparent viscosity of a non-Newtonian fluid was found to be 1 Pascal second. At a shear rate of 100 second inverse, the apparent viscosity of the same liquid was found to be 0.5 Pascal second. If the liquid follows power law behavior, the apparent viscosity in Pascal second at a shear stress of 10 Newton per meter square is dash. So over here we have been given a non-Newtonian fluid for which the equation correlating the shear stress and the shear rate, we can write it using the power law model. So according to this power law model, the shear stress, that is tau, will be equal to apparent viscosity times dvx upon apparent viscosity times strain rate. And apparent viscosity, we can write it as mu naught dvx upon dvy is to n minus 1 dvx upon dvy. Okay, now over here we have been given two different scenarios. So let's just write for case 1, the shear rate, that is basically this term dvx upon dvy, we have been given as 10. That is dvx upon dvy for first is 10, and the apparent viscosity is 1 Pascal second. Basically this term we have been given it as mu is equal to 1 Pascal second. Now for the second case, we have been given dvx upon dy for second case is equal to 100, and the viscosity of the same fluid was 0.5. It is mu is equal to 0.5. Now we have to find the apparent viscosity at a shear stress of 10 Newton per meter square. So the apparent viscosity is mu naught dvx upon dvy raised to n minus 1. So we have to find this value when the shear stress, that is tau, is 10 Newton per meter square. So for that, we need to find the value of mu naught and n. Then we can replace it in this equation to find the value of shear stress. No, to find the value of the apparent viscosity at a shear stress of 10 Newton per meter square. So let's just first utilize the information provided by this case 1 and case 2. So for that, we can write the relation between this apparent viscosity as, let's say, mu2 upon mu1 is equal to 0.5 upon 1 is equal to mu naught upon mu naught, that will be the same, and dvx by dvy for second case was 100, and for first case it is 10 raised to n minus 1. So this will get cancelled out. From that we will be having 0.5 is equal to 10 raised to n minus 1. Now from here we have to find the value of n minus 1. So we can take the log on both the sides, and ultimately we will be getting the value of n minus 1 will be minus of 0.3. So the value of n will be 1 minus 0.3, that is 0.7. Now we have the value of n is equal to 0.7. So using any of the case 1 or case 2, we can find the next value, that is the value of mu naught. So over here, let's just use the information from case 1, that is mu 1 Pascal second is equal to mu naught raised to dvx upon dvy raised to n minus 1. So 1 is equal to mu naught. Strain rate was 10 raised to n we found out as 0.7. That is minus of 0. So from here we will get the value of mu naught as 1 upon 10 raised to minus of 0.3. So this will come around 2. The value of mu naught is 2. Now we have to find the apparent viscosity for a shear stress of 10 Newton per meter square. So for that, first we need to find the value of the shear strain. Now the strain rate at this 10 Newton per meter square, that is we have to find dvx by dy. Now this we have to find. So for a shear stress of, let's say, tau is equal to mu. Mu is the apparent viscosity, 1 dvx, 1 dvy raised to n we can write, and tau we have been given as 10 is equal to the value of mu we found out as 2. So it will be mu naught times of dvx by n raised to this term. Okay, so over here it will be in this mu naught. Dvx dx and raised to n. So the value of n is already 0.7. Using this, the value of dvx by dy raised to 0.7 will be 10 upon 2 is equal to 5. So dv by dy will be 5.17, and we can solve this and find out that the strain rate will be 9.966. Now we have to find the apparent viscosity, that is mu in this case. So mu is mu naught dvx upon dy raised to n minus 1, and we will replace all the values, that is 2. From here we have this value 9.96 and n was 0.3, so n minus 1 will become, n was 0.7, so n minus 1 will become 0.7 minus 1. So we can solve this, and the value of mu, that is apparent viscosity, will be 1 Pascal second. So the final answer we will write as 1.